In this session of our video lecture series on factoring techniques, we will learn about factoring the difference of two squares. Let's begin by examining pairs of factors and making observations about them. What do you notice? How are they the same? How are they different? Note that in each pairs of factors, the first terms are identical, and so are the second terms. They are different in that in one of the binomial factors, the operation is addition, while in the other, it's subtraction. In other words, the operation in one pair is different from the operation in the other pair. Now, try multiplying each pair of factors in your notebook. Pause the video now and play when you're ready with the answers. Okay, for the first pair, you should have gotten the answer x squared minus 4. In the next one, x squared minus 25. Next, y squared minus 36. And in the last one, 4x squared minus 1. Now examine these products. What do you notice? How many terms are there in each product? Note that each product is a binomial, so there are 2 terms. Now, what is the operation in each of those products? Notice that in each of those products, your operation is subtraction. What do you observe about the terms in the product? Let's look at the first one, x squared minus 4. So you have x squared and 4. In the second one, x squared and 25, and so on. What do you notice? That's right. These terms are perfect squares. Remember that perfect squares are numbers or expressions that are squares of other numbers or expressions. In other words, they may be written as something squared. That means that the product is a difference of two squares, and the factors of which are two identical binomials except for the operation. A difference of two squares then is a binomial in the form a squared minus b squared. In this case, the factored form of this binomial is a plus b multiplied by a minus b. Now let's try out an example. Number 1, factor x squared minus 100. Remember that when you're factoring a binomial, that binomial is possibly a difference of two squares because of it being a binomial. But remember, being a binomial is not the only requirement for being a difference of two squares. The operation must be subtraction, and the terms must be perfect squares. In this case, both characteristics are also present. That means I can express my original binomial as x squared minus 10 squared. In this case, we factor it as x plus 10 multiplied by x minus 10. Next one. Let's factor b to the fourth minus 9. Once again, we need to meet the three characteristics for this binomial to be a difference of two squares. Again, it's a binomial, so you have two terms. The operation is still subtraction, and b to the fourth and 9 are perfect squares. That means I can rewrite my expression as b squared to the power of 2 minus 3 squared. So we factor our binomial as b squared plus 3 multiplied by b squared minus 3. Another one. Let's factor s to the 10, t to the 8 minus 49. Once again, this binomial has two terms. The operation is still subtraction, and the terms are perfect squares. We express this binomial as s to the 5th, t to the 4th raised to the 2nd power minus 7 squared. We then factor this binomial as s to the 5th, t to the 4th plus 7 multiplied by s to the 5th, t to the 4th minus 7. Now try these on your own. Also, in your notebook, tabulate the squares of the first 20 natural numbers. You have to master these squares so that in future solving exercises, you'll have to do them much faster, like this.